Now, some of you I don't think were here on last Thursday. So are you using, I think I'm actually just looking at you. Are you using Windows or are you using Mac? You're using a Mac. Okay, so what you're going to want to do is somewhere on your Mac, you have an icon that looks like this, right? This sort of launch pad. And so you are going to have an icon. You're going to have an icon that says Other. And in Other, you're going to look for an icon that reads Terminal. And in fact, if you don't want to do that, another way to approach this is to open up Launchpad. And at the top here, start writing TERN. You're probably only going to see one icon. So go ahead and click Terminal, and that's going to open up a terminal. And you can make that larger. I always do anyway. So now what you're going to do, presumably you still have the same password that I created for everybody else. So what you're going to do is you're going to type the following. And of course this applies for everybody who's using OS 10. If you forgot, this is good review. So you're going to type not OS 10. You're going to type SSH and then your net ID. And mine happens to be MACLACH. So that's going to be the part of your email address before the @ symbol. And then you're going to type 76.106.8.87. Did it work? No pressure. We're all just waiting on you, though. Oh, well, actually, when you type your password, nothing's going to appear on the screen. The cursor won't blink. The cursor won't move. Yep. Oh, sorry, let me get out of your way. Okay, so let's give her a second to get caught up. And then what we're going to do is the following. To reset your password on this machine, all you do is type PASSWD, hit enter, and it's going to ask you for your current password. Now again, before half of you get lost here, if we've already reset your password, you don't need to do this. So it's going to ask you for your current password. And then it's going to ask you for your new password. Now notice, when it asks you for your new password and you start typing, nothing is going to appear. This is in case you have a nosy friend who's looking at your terminal and you don't want them to see your password, right? So nothing is going to appear. All you're going to do is just type your password in, and then you're going to hit enter. You're going to retype your password, and if you're going to retype your password, then hit enter again. And if everything works great, it's going to say authentication tokens updated successfully. Now I'm not going to change my password because I actually really like my password, and if it says bad password based on a dictionary word, well, it's a bad password and it's based on a dictionary word. So try something a little bit more creative. And by the way, if you are getting bad password based on a dictionary word, that's fine. You do know how to update your password now, PASSWD, and just go home tonight and think of like a really creative password. But okay. So again, if you're getting bad password based on a dictionary word, let's not stop the lecture. Let's just keep going with it, and you can go home tonight and try to think of a better password. Like a good password is something that has a lot of entropy. It's very difficult to guess. Like a good password would be something like this, for example, right? Very difficult to remember, very difficult to guess. Okay, so again, I've said this before in the last lecture. This is not a class based on SQL. right? In fact, in order to capture my voice, I think I am going to use this thing here, so I'm going to feel a little silly, but this is too loud. Let me know. So this is not necessarily a class based on SQL, but SQL is such a vital part of what we're going to be doing that you need to know a little bit to get by. And I'm not going to throw anything at you that is extremely difficult. In fact, to be quite frank with you, all you really need to know about SQL is probably 8 or 10 commands that are repetitive, right? And you're going to sort of get this muscle memorization thing going on here. If you forget what you've learned, remember you can always scroll up and look at your MySQL history. And I'm not really going to throw anything at you. I don't think I'll throw anything at you that's not in the slide deck. So that being said, let's make that go away. These are the commands that we're going to be taking a look at tonight or today. So these are the SQL commands that you're going to learn. I would go through the list and read them to you, but that's probably a waste of time. Some of them you're already familiar with. Now, typically, I would split this across 2 lectures because it is kind of a lot. But because this is an accelerated course and I do have you for 2 hours and 20 minutes, I think I can get through all of it. And again, my job is to try to deliver this material in such a way that doesn't put you all to sleep. I don't know if I will be successful, but if there's something that you've missed, you know, you're always welcome to stop me after class and ask me to shoot me an email. And again, because I realize that this is sort of, well, this is going to be a densely packed lecture, I'm also going to be recording it, and I'll post the lecture online so you can go back and review it. So, having said that, well, let's log into our MySQL databases. So each one of you, if you have filled out your name and your net ID on the class spreadsheet, each one of you should have an email from me somewhere in your inbox that either says something to the effect of, this is your MySQL password, or if I was doing this in a rush, I just sent you your password in the subject line. But each one of you should have an email from me. And so how are we going to log into our MySQL database? Well, first things first, everyone should have on their terminal a prompt that looks like the following. Your net ID at DATS6102. If you see that, good, you're in the right place. Okay? So, you do the following. You type MySQL-U for username, and then you provide your username, which is going to be your net ID, and then follow that with a space and a -P. And then you're going to hit enter, and you're going to type in the password that I gave to you, and you're going to hit enter again, and you're going to hope for the best. By the end of this week, this is going to be old hat to you guys. You're going to be like, oh, this is nothing. It's easy. This is easy. But it can be a little difficult at first. So, I don't know any of your names yet. I kind of know some of you by net ID. So unfortunately, I can't start singling you guys out and calling you by name. But actually, I think I know your name because you emailed me today, but I can't pronounce it. So you're in luck. But so recall last time, when you log into a database for the very first time, and for some of you, that is happening right now. When you log into a database for the very first time, what perhaps is the thing that you want to do first? Awesome. And so how would I get MySQL to bend to my will? Sure. And so show databases. Yep. Is MySQL case sensitive, by the way? So for example, if I type show databases, is MySQL going to listen to me? Well, yeah. On my operating system, it actually depends on the underlying operating system. OS X is actually not a case-sensitive operating system, so it lets you get away with it. By convention, and you don't need to memorize this, I suppose, but by convention, MySQL keywords are always typed in capital letters. It just makes the world a little bit easier. And I'm going to follow that convention to the extent that I can remember to do it. So I'm going to type show databases. And all of you should see something very similar to what I'm seeing. So I'm seeing information underscore schema, and I'm also seeing McLockDB. All of you should have databases that are your net ID followed by DB. Do you guys see that? Okay, good. So let's suppose I want to use, let's say I want to use McLockDB. Remind me, how do we go ahead and do that? Okay, so use McLockDB. And by the way, McLockDB is not a MySQL keyword. That's actually a variable. And so that has to be typed out exactly as it appears. So for example, if I do McLockDB, that's not going to work because it says I don't even know of a McLock capital D, capital B. So this has to be, the variable names have to be typed exactly as they appear. Great, so I'm using McLockDB. Remind me again now, what do I do now? So I've looked at my databases, I've selected a database. Sure, I'm going to show tables. What tables do I have available? Well, I actually have a lot of tables. You guys presumably have none. You might have one. If you're really ambitious and went ahead with the assignment, then you might actually have one table. If you did go ahead and create a table, that's great, I'm happy. But I'm going to take a few minutes now and show you guys how to pull a table into your database if you haven't done so already, okay? The table that we're going to use, so this is your first new material. This bit here is going to be your first new material. Go ahead and type exit. We're going to log out of MySQL. Anyway, I know that this is a little bit slow. I actually feel it's a little bit slow, but I promise you that this is really going to be, these are the sort of basic skills that you are going to come to depend upon in architecting out your data warehouses. So, there's a class directory that we all share. Can somebody remind me where that directory is? You could probably up arrow or type history to find it, but well, let me be the first. So there's going to be a we're going to want to cd into /DATS6102, and that's the directory that we all share. And if I type ls, you're going to see the contents of that directory. Everything that's green will be a file. Everything that's blue will be a directory. And that pink thing, that's a really annoying tar file that contains an ETL application that's written in Java very poorly and it always crashes. We're going to look at it at some point, but it's a terrible application. So, and what we want to look at is example01.sql. So here's what we're going to do. We're going to pull that file into our home directories. So in order to get home, I'm going to type cd, and that's going to take me to my home directory. And how do I know that I'm in my home directory? I'll type pwd, and I'm home. So let's bring that file over to our home directory. We're going to use the copy command. You're going to use this quite a bit too. We're going to use the copy command, which is cp, the target of the copy. So the name of the file that we want to copy. So it's going to be /, and I'm going to type the letter D, and because I'm good like that, I'm just going to hit tab, and it's going to autocomplete for me, so I don't have to type it all out. Or not. There it goes. And then I'm going to bring example 01 over to my home directory. So don't hit enter yet. Well, if you do, you're just going to get an error. Now my home directory is /home maclach, but that gets kind of annoying to write all the time. So you could write that, but a simple shorthand is just to use the tilde. And that's going to bring example01.sql into your home directory. If you guys enter this command just as I have and then hit enter, it's going to bring example01.sql into your home directory. Sometimes people make mistakes. I see this quite a bit where, for example, they'll forget to put a white space in between the source and the destination. So remember, cp, a space, the name of the file, another space, and then the destination. The destination is going to be your home directory. So pay attention here and type this exactly as you see it. This is one of those commands that it's not going to go away. This is something that you're going to be using over and over and over again. In the way that the Unix world works, if a command completes successfully, it doesn't tell you anything. There's no output. So if you hit enter and you get a new line, a new prompt with no output, then it worked successfully. An example of it not working successfully is if I were to do this. So I dropped the tilde here. I didn't give it a target to copy the file to, and then it says all sorts of things like missing destination, etc., etc., etc. But if it works properly, it's just going to give you a new line, and you're going to keep going. Yeah, so if it's already there, if I do this over and over again, it's just going to keep copying the file back. It'll keep rewriting the file. It'll keep bringing it over and rewriting it again. So you don't have to do this, but let me show you what it is that you just copied over. You don't have to you can do what I'm doing here, but you don't have to. What I'm copying over here is that student create table file. So we're all going to create a table in our database called student. And we did go through this last time, so really quickly I'll go through it again. The very first line of this file is going to be the following. If there is already a student table in your database, it's going to delete it. So that's the first thing that's going to do. Drop table if exists. Oh, and by the way, we will go through the sort of the grammar of these commands through the course of tonight's lecture. So don't get too stuck on trying to memorize these things. It is going to become more clear as we go through. In fact, I have an entire slide dedicated to dropping tables. Yeah, but the first thing we're going to do is if a student table exists, we're just going to wipe it out. And then the next line, I'm going to create a student table. And by the way, notice that there are line breaks here. So I have create table student and then open parenthesis. The close parenthesis that matches that is down here. So what I'm doing here is I'm creating, well, let me ask you, how many columns, how many fields am I creating in this table? What? There are 5 columns that are being created. And the column names are ID, F name, L name, you can probably guess what that means, age, and GPA. And we also talked about the types. So for example, file name, first name is going to be a character string up to and including 30 characters long. Last name is going to be the same. Age is going to be an integer, and GPA is going to be a double. And remind me again, what does the 3, 2 mean? What? Yeah, so what I'm going to do is I'm going to show 3 digits, that's what the 3 means, but I'm going to keep 2 digits behind the decimal point, that's what the 2 means. Okay, I did skip a variable, I skipped the first one, that's going to be ID. So ID is also going to be an integer, but there are a couple of other qualifiers that I'm going to be adding onto this. I'm not going to allow ID to be null. And what does it mean to be null? It's going to be empty, right? So ID has to have a value. If I try to enter a row into the database and I don't have ID specified, it's going to give me trouble. It doesn't want null values. Although in this particular case, I do something tricky here. I use the auto increment qualifier. And that means the following. If I don't supply an ID number, MySQL is going to go and look at the greatest ID that it stores in its database and simply add 1 to it. That's what auto increment means. Yeah. No, actually, that'll give you a different error. And why is that? Because we actually, we're setting ID to be a primary key. And remember, we talked about that last time as well. So a primary key is the unique identifier. And if you try to enter a duplicate primary key, it's going to say error, cannot enter a duplicate primary key, or primary key is duplicate. So you would have to go back and fix that problem. You'd have to, remove the for and let MySQL assign whatever ID it wants based on the next highest ID number, or you'd have to specify the ID by hand. Mm-hmm. Yep, you could do that also. So we're going to upload this to our database. Now there are a couple of ways that you could do this. You could actually just go into MySQL. You could open up 2 terminals. In fact, it's crazy to not have more than 1 terminal open anyway. But you could have 2 terminals, and you could just simply begin by copying and pasting line by line into MySQL. But that's a sort of clumsy, naive way to do it. Especially if your table has hundreds or thousands of columns. You're not going to copy and paste thousands of columns. That's not really an effective use of your time. So what we're going to do it smartly. I'm going to show you how to take this file, a .sql file, and upload it into your database. So you do it like the following. You type MySQL -u, your username, -p, everything is the same so far, right? But here's where it gets different. So don't hit enter yet, because all that's going to do is prompt you for your password and then log you into MySQL. What we're going to do is we're going to take this file and we're going to basically read it in line by line into MySQL, and MySQL is going to follow all of those instructions procedurally. So in order to do that, we're going to do a -D. And -D, by the way, means specify the name of the database that you want to use. So for example, mine is going to be McLockDB. But don't hit enter yet. We're not ready yet. Then what you're going to do is you're going to use an operator. It's called the Indirection Operator. I won't quiz you on the name of this operator, but from time to time I'm going to refer to it by name, and so it's good if you guys know what it is that I'm talking about. So I'm going to use the Indirection Operator. And on the other side of that indirection operator, I'm going to specify the name of the SQL file that I want to upload. So, drum roll. If you guys hit enter now, then with a whole lot of luck, it's going to prompt you for your password. You're going to put your password in, and if all goes well, you're just going to see a new prompt. And if it does work, then pat yourself on the back because you're now a MySQL database admin and you have just uploaded your first SQL file. No, you would use the password that I emailed to you, or if you came to me for a new MySQL password. So yeah, don't be confused. That's a great point. You have two passwords. One of them is to log on to the server, and one of them is to log into the database. So you're going to be using your MySQL password, right? Not your SSH password. Did you get it? What's your name, by the way? I'm going to actually start.
My name's Dan.
Dan, how'd it go? You look satisfied. You look happy. So excellent. Yeah, so that works. Oh,
I'm expecting to.
yeah, so that's not going to log you in. If you see enter password and then blankness and then a new prompt that says your net ID, et cetera, then it works. And if you want to check to see if it works, go ahead and log into MySQL. Oh, and by the way, save yourself some typing and just up arrow and delete all this nonsense back to the -P. And then log in. Well, I know what I want to do. I want to use my database, use McLockDB, and then do show tables. And if it did work, don't be like me, try to type correctly here. So if it did work, you should see a student table now in your database. Is anybody having trouble? I show hands, I can walk around and help assist. So now you should all have a student table that has nothing in it. And so if you want to take a look at that table and interrogate it, see what's, how it's comprised, then type describe student, followed by a colon or semicolon, and then hit enter. And you should see something that looks like this. So now I'm going to show you your first query. It's probably the hello world of queries. It's a very simple query. What we're going to do is we're going to try to find out what's in our table. And so, and by the way, so we're going to start looking at select queries. And if you're looking on the slide deck, the second slide that we're looking at tonight, we started here. Oh, and I should probably point out to you, by the way, there are some good learning resources for SQL here. I provide a couple of links that you can go to and sort of poke around on your own time if you want to learn a little more SQL. On the second slide that we're going to be looking at, there's an example query. And I sort of give you the full gory details of the canonical select query. I'm not going to start out with select in all its gory detail. We're going to start out with simply and sort of build up. So the first select, well, we already looked at this. We've already looked at this as well. Loading an SQL file. Presumably you've all gotten to this point. So what we're going to start doing, well, we're not going to do the inserts either. But the first thing we're going to do is we're going to try to select from our table and see what's there. And so this is basically your simplest select query. So once you're logged into your SQL database, type the keyword select, and then you're going to select everything. Let's just select everything in our database. Now, there are a couple of different wildcards. A wildcard is a variable which gets interpolated with anything. So in a select query, the wildcard that you're going to use is an asterisk. I'm going to select everything from the table name student. So the syntax of that query that we're going to be using is select asterisk from student semicolon. And you're going to see empty set because there's nothing in that table. We have to go ahead and add some data first. So let's go ahead and add some data.
It's 7 o'clock.
And if you look on slide 20, I have a number of insert commands that we're going to use to insert data into the database. And I was fairly careful about this when I created these. And so you can pretty much copy and paste these commands, or at least type them verbatim into your terminal and start adding data. So the first thing that we're going to do is we're going to insert. So the syntax you're going to be using is insert into table name. You're going to open up a set of parentheses, and you're going to specify all of the column names separated by a comma. So it's going to be comma-separated list of columns or fields that you're going to be inserting into. You're going to close parenthesis. You're going to give the keyword values, and then open up another set of parentheses and give a comma-separated list that corresponds to the fields that you're populating. So the first value is going to go in the first field, the second value will go into the second field, and so on and so forth. So the command that we're going to use first to start putting some data here is, well, if you're using OS 10, I'm pretty sure that you can just go ahead and copy and paste. I'm not sure about Windows, how to copy and paste with it, but you can sort of hack your way through it and just type it in by hand. So we're going to insert into table student ID, fname, lname, age, GPA, the following values. So we're going to give the ID 10, first name Glenn, it's me here, last name McLaughlin, age 44, and then GPA 4.0 because I have 4.0. Bless you. So that went pretty quick there because I simply copied and pasted it, and it had a trailing new line, so it hit enter for me by default. But if it worked okay, it's going to say query okay, one row affected, and it took 10 milliseconds to accomplish this query. Well, this insert command. And so now remember, if you want to retrieve a command that you've already used in MySQL, you don't have to type it out. You can just up arrow. So let's up arrow a couple of lines back into our select everything from student, hit enter, and see what's there. And you'll notice now that we have a row in our table. So we're taking really small steps, but we're actually populating our, well, our relatively modest data warehouse, but we have to start somewhere, so. And again, I told you that I'm going to teach you how to write code that will do this for you. In fact, we'll even go a little bit further. We're going to write code that will write the code that will do this for you. But we're going to do a few by hand just so you get the hang of it. So let's go to the next line. Let's add my brother to our database. Now notice here it's a little bit different. When we added me, I specified all 5 columns. Specified ID, Fname, Lname, age, and GPA. But in this case, we're going to specify only first name and last name. I'm not going to specify what the ID number is. I mean, it should be 11, I guess. Maybe not, but we're going to specify just the first name and last name. And we won't specify his age because I don't want to embarrass him, he's old. And we're not going to specify his GPA because that would really embarrass him. So let's go ahead and add my brother. And if we up arrow a couple of times to go to select everything from student, well, what do we expect to happen now? What do you expect his ID to be? We didn't specify it, but we did use the auto increment keyword. So what do you think his ID is going to be? Remember, mine was 10. So his is going to be once, right? Oh, maybe I should have set up his age to be null, in the default to be null. It's actually specifying his age to be 0. That's probably bad design. Why is that bad design? Well, if I don't know his age, I shouldn't pretend that he's 0, right? So I'm guilty of bad design already. So I guess I should go back and maybe wipe this table out and then set up the age so that if there is a null variable, it's populated as null rather than 0. But well, let's not worry too much about that at the moment. So let's add a couple more, and then what I want you guys to do is just take a couple of minutes, and it'll sort of be like a Catholic wedding where you look to the left and look to the right and shake hands, and then get people's information, and then put a couple of entries into your own database. So let's put in George Washington. So it's going to be very similar to mine. I'm going to specify all of the columns. I think George is probably 284 right now instead of 283, but whatever. And let's also put in Martha. Apparently Martha was a good deal younger than George. And if we up arrow again, You see we have 4 rows in our database now. So what I'd like you to do, I want a little bit more data in our database. So do me a favor and just look to your left or look to your right, or make them up. I don't even care, actually. You can add whoever you want, but it's more interesting and it's better to get to know your classmates. Just go ahead and ask. Well, I guess you don't have to ask GPA. You can assume everybody's getting a 4.0. I mean, data sciences, everybody's an excellent student. I'm sure they're getting 4.0s. So you can also just leave that blank, by the way, and that's going to be populated as null. But go ahead and just ask the person to your left or right, and put a couple of more rows into your database. Okay, I actually snuck something in there with Martha, and I'm going to show you again. If you recall, actually, let me turn my, let me get mic'd up again. So if you recall, I showed you the sort of canonical way of inserting data into a MySQL database is to supply, within parentheses, a comma-separated list of the column names or the field names. But if you note, and I did that in my first 3 examples, but if you notice in the 4th example, when I entered Martha's data, I didn't specify the column names. Well, it turns out that in MySQL, if you're going to supply every field in order so that there is no way of making a mistake or there's nothing ambiguous, MySQL, or SQL in general, is smart enough to know that, okay, I didn't specify the column names here where they should go, but it knows, okay, this is an integer, this is a var char less than 30, this is a var char less than 30, this is an int, this is a double that conforms to the rules that I specified. And if I do that, if I specify all of those column values, I don't need to specify the column names. So if I go ahead and if I insert ID number 8, Alexander Ovechkin, age 30, GPA's 4.0, I don't have to specify the column names. Now, something sort of interesting here, too. Let's suppose that if I do specify the column names along with the values, I can mix up the order. So let me actually specify, I'm going to specify first name, last name, actually, I'm going to do last name first and first name last. And then I'm going to do ID. So if I do, for example, last name first, like I can do, for example, Holtby, Braden, and then specify an ID. Well, by the way, I don't have to surround in single quotes numbers like integers. If I declare it to be an int, I don't have to surround it with single quotes. So for example, I can mix up the order here. So I have last name first, then first name second, and then I have the person's ID. And since it's an integer, single quotes only are really required when I'm entering a char, a character string. But if I'm not entering a character string, I don't need those single quotes. So let me actually select some data here now and see what I've got. That's great. I've got like, I don't know, 6 rows. Okay. So now I'm going to go, now that we have some data in our database, I'm going to go through some interesting selects. We've already looked at one of these, the select everything from student. But I'm going to show you some other ways to do some selects to sort of slice through your data. Let's do the following. Rather than selecting everything, I'm just going to select last names from table student. And I'm going to see Ovechkin, McClock, Washington, Holtby. Okay, that's great. You notice I have some duplicates there. I have McLaughlin twice, Washington twice. So the first thing that I'm going to show you is how to remove the duplicates in your query. Okay. So I'm going to select distinct last name from student. And if I hit enter here, it's only going to give me one occurrence of each unique name. Now sometimes, by the way, I'm going to be doing queries. Well, more often than not, your queries are going to involve multiple tables. We only have one table here, so it doesn't really matter. But more often than not, your queries are going to involve multiple tables. And for example, you may have L name or last name appearing in more than one table. How do you tell MySQL which table you're querying? You do that doing the following. The syntax that you use is, well, select distinct. I can remove the distinct. And you can keep it if you want, but for what I'm showing right now, distinct doesn't really matter. I can do select, and then I specify the name of the table. So select student dot lname from table student. Now you may say, oh, but wait a second, I've already specified which table. And yeah, if you only have one table, this kind of is redundant. But you may be specifying, you may be querying from more than one table. Maybe I'm going to specify from student, and the other table is going to be class role, or maybe it's going to be, I don't know, whatever table name it is. And lname may appear in multiple tables. So even though I'm going to specify all the tables that I'm querying, following the keyword from, I still can, I can be precise, and I can specify which table lname I want to pull from. Okay, so let's continue on. This is where it starts to get fun, right? So what I'm going to show you now is using select with the where clause. So now I'm going to start putting cuts or filters on my queries. So suppose I only want to select first name for student from student where age is greater than 50. So it's going to skip me for a few more years. It's going to skip Alexander Ovechkin, but it's going to pull Martha, and it's also going to pull George. At least it should, right? So, and again, you can copy and paste, or if you want to practice your typing, feel free. Select F name. I'm going to do L name too, because I want to show you how to actually get multiple values. So I'm going to do F name, L name, and age, and that's just going to be a comma-separated list. Notice I'm a little sloppy with my comma placements. MySQL doesn't care. Select from student where age is greater than 50, semicolon, and then I hit enter. And again, if you've done MySQL or SQL before, this is probably going to seem sort of rudimentary. And it is rudimentary, but again, we've got to start somewhere. And Well, you may not remember everything we do tonight, but by the end of this evening, you guys are going to be, you'll be on your way to being SQL gurus. And we'll be able to do some interesting queries. So we used an operator there. We used the greater than symbol. That's actually a comparison operator. There are a number of operators that we can use in MySQL, and I give some of them here. There is, well, actually, I'm not going to tell you what this operator is first. I'm going to save this one for last. There's the greater than, the less than, the greater than or equal to, and the less than or equal to. In this operator right here, well, MySQL has a really silly way of saying not, N-O-T, the logical negation. In a lot of languages, well, in a lot of languages, if you've done any programming at all, or so you might be familiar with seeing the negation as an exclamation point. I'll even try to be fancy and do it sort of. The exclamation point is not. And sometimes in some languages, it's actually exclamation point equal sign together means the negation means not. But for reasons which utterly defy my understanding, the way SQL does not or negation is the less than or greater than sign pointing at each other like that. That means not. I suppose it makes sense because you know, if you put an A here and a B here, there is no, it's an empty set. There's nothing that can be both greater than and less than at the same time, right? Logically, it doesn't make sense. So, okay, fine. Oh, and of course, did I miss the equal sign? So anyway, let's select only those values where age is 283, and that should only be George, right? We can select all the values that aren't 283 by using the negation operator. So that's going to be everybody but George. So we're actually doing set theory here, using SQL as our canvas, our backdrop, so to speak. Okay, I'm not going to do any more examples with the comparison operators because I think we've covered all of them. And it should be intuitive how they work or how they behave. If there are questions, certainly stop me. Okay, so here we're going to use the between clause. So this is kind of an interesting approach to doing queries. Let's suppose I want to select first name, or maybe first name and age or whatever, from student, where age is between 40 and 50. I'm going to save myself a little typing here and just copy and paste this. So I'm going to select from student. I'm going to select first name, and let me select age also, just so we can see that it's working. I didn't mean to do that. What did I do? There we go. I'm going to select first name and age. Well, let's do between 0 and 60, because my brother is 0 years old as far as SQL is concerned. Let's see if he gets included or not. So is this going to be inclusive or exclusive? Oops. So far, so good? So for the next example, I'm just going to do a straightforward select again. I'm going to select first name and age from student. And you'll notice that this is an unsorted list. I haven't sorted by alphabet, and I haven't sorted by age. Sorts are actually very expensive in SQL. This is a very short list, and sorting a short list is trivial. But it will not be uncommon for your SQL databases to have tens of millions of rows, if not more. And sorting a database that is that long can be prohibitive. The database, the public database that I maintained that I allowed you guys to browse last time, I think it has, I don't even know, to be quite honest with you, how many millions of rows. But a sort can take a poorly crafted query with a sort in place, I found can take upwards of 15 minutes or more. And again, I apologize, I should know how many rows are in the database, but there are, well, several million anyway. So sorts are actually, really costly and time-consuming. And as a data warehouse architect, you're going to want to set your data warehouse up so that you do your sorts, or you do the sort of typical sorts ahead of time for your analysts. However, well, we're going to sort of punt and worry about that a little bit more later on down the road. But in order to do a sort in SQL, even a simple sort like this, we're going to do the following. And by the way, this is on the next slide. So I'm going to start with selecting first name and age from my student database. And then I'm going to use the keyword order space by and the name of the variable that I want to sort on. And I want to sort on age. So that's how I sort in SQL. I could also sort lexicographically. Here I'm sorting numerically. I can also sort lexicographically. And I could order by name. So now I'm ordering lexicographically. In fact, I could even go further too. Let me do last name, first name. So here we have, I'm sorting by last name. So I have Holtby, McLaughlin, Ovechkin, Washington. But I can actually sort hierarchically. So I can do a comma-separated list on my ordering. So I could order by last name, and then I could say comma, order by age. And now you'll see my brother Scott, who's only 0 years old. Now he comes before me. And Martha now comes before George, where in the previous example, those two were interchanged. So order by is hierarchical. I can specify which variable I want to sort on, and then I can say, okay, within subcategories that have the same last name or whatever the variable may be, I can sort again and again and again. So this is a hierarchical or a nested sort. Okay, let's go on to the next one. Okay. This is actually a very special query, and you're going to be using this query quite a bit. It has another name that we haven't gotten to yet, but we will. This is actually called drilling down. You may have heard that phrase used before, drilling down into data. Well, drilling down into data simply means adding a new column and grouping by that column. And this is how we drill down. So let's take a look at this. It starts out with a relatively simple familiar query. So I'm going to select last name, but there's a random keyword here, count. Count is a function. And so it takes an argument. That would be the asterisk. And so what count says is, essentially what count is going to do is going to count all the occurrences of a last name, every occurrence. So it's going to count, for example, oh, and by the way, I could replace this with L name. I could replace it with F name, but then the behavior is going to be a little bit, well, unpredictable. But what it's going to do is it's going to count every occurrence of every name. So, for example, for Ovechkin, it should have a count of 1. For McLaughlin, it should have a count of 2. And Washington, it should have a count of 2. So, and I also need to group by this. So I have to categorize. I have to group by the variable that I'm drilling down into. So let's go ahead and run this query. Select last name, count the number of last names that appear in that category, and group by last name. And again, I'm going to save myself a little bit of typing. Now this is actually a very useful query because it allows me to generate interesting reports pretty quickly. You know, instead of last name being McLaughlin or Ovechkin or Washington, this could be, for example, maybe you're doing a sales report and you are going to, so for example, okay, here's where it actually gets really interesting. So I can do fuzzy searches. I can do searches, I can do queries, where I don't necessarily know what it is that I'm looking for. And I'm going to introduce 2 additional wildcards. So one of the wildcards that we saw already was the asterisk. You can see it up here, this query. Select everything from student where last name is like Washington. Well, the other 2 wildcards are going to be the % symbol and the underscore sign. And they have similar but somewhat different meanings. So the % symbol means the following. It means match any number of occurrences, including 0. Any number of characters, including 0. So for example, well, actually, I'll give you an example when we get to the terminal. The underscore means match 1 character. So let me show you what that means. So I'm going to select everything from student where last name is like Washington. Well, Washington works out pretty well because I have exact matches. But what I can do is the following. I can say, well, maybe I don't know it's Washington. Maybe I'm looking for some guy, maybe his last name is Washburn or Washboard or whatever. I can do a fuzzy search by doing like Wash %. And that still finds everybody who's named Washington. In fact, if memory serves, I think I only need 3 characters. So I think as long as I know it's WAS, something, 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 I can still do a keyword, I'm sorry, a wildcard search on Washington. Is that true? Actually, I might be lying to you. I think I am. Yeah, so I am lying to you. I'm thinking about text blobs. But what about the following? What if I do this? Maybe I don't know if it's Washington or Washington or Washington whatever, right? So what I can do is I can use an underscore, and that represents a wildcard, a single character wildcard. But if I use 2 underscores, it doesn't find anything. Well, that's kind of interesting. Let's go back and look at the other wildcard. Let me substitute my 2 underscores with a my good old handy match anything, including nothing, %. Well, that's going to find Washington. And okay, well, maybe I can have a couple of %signs here. I can go crazy with it, and it's still finding Washington. So I can sort of stack these match anything or nothing wildcards, and it still finds Washington. The reason it still finds Washington is because, well, I don't need any. Oh, actually, let me put the T back there so I'm spelling it correctly. It's still finding Washington, but the reason that works is because it also matches 0 number of occurrences. On the other hand, the underscore matches 1 and only 1 occurrence. And so this means that I'm looking for somebody whose name is washing with something else that cannot be empty and that ends with TON. So this will not work. It may take you a couple minutes to get your head around this. It's actually not a very difficult concept, but if you haven't dealt with wildcards before, sometimes it's a little bit unclear why they behave the way they do. Where this will come back and burn you is not on an exam, most likely. I'm very forgiving about wildcards. But when you're actually doing a wildcard query in a professional setting, you could end up searching for something that you don't realize you're searching for. So it is good to know how your wildcards work. Any questions so far? I think I'm sort of going through this relatively quickly without soliciting feedback. Okay. What is next? So somebody asked me before how to edit a field, how to edit a row. Sometimes you bork an insert into your database and you need to go back and fix it. So this is how we're going to do that. We set my brother's age to be 0, right? Well, let's go back and fix that now. So in order to fix that, we're going to use we're going to use the update query, the update keyword. And I'm going to update a table. So here's the canonical syntax. I'm going to update a table name, and I'm going to set some variable where, and then I specify a condition. So the example I'm going to use here is my brother is 54. So I'm going to update student, and I'm going to set age is equal to 54 where, and here's where I can get creative with the condition. Well, maybe I update on first name Scott. Well, there could be a lot of Scotts in that table, so that's not such a great thing. I could update where last name is McLaughlin, but this is set my age to 54. And I certainly don't want to do that. So the most sensible thing to do is, well, let's remember, our table has a primary key, and what is that primary key? It's a unique identifier. Every row has a unique identifier. So if I'm going to update a particular row in my table, I might as well use my primary key. That's why they're there. And, well, this is an old slide, so I'm not really sure who's who. You can see I'm already getting lazy with my uppercase and lowercase. So Scott, he's user ID 11. Let's set that guy to 54. Actually, he's 55. And it's an integer. Yes, you're right. Yeah. So let's go ahead and set his age to 55. Query OK, 1 row affected. I love that message. You're going to learn to love it too because it lets you know that things worked. 0 warnings. Sometimes there will be warnings too, by the way, and not in my queries because my queries are perfect. Sometimes there are warnings, and If there are warnings, you can just type show warnings, and it'll tell you what your warnings were, but your queries are going to be perfect too. So if you get a lot of warnings, let me know, and I'll show you how to sort of go through those. So let's take a look again. And now his age has been updated to 55. So that is how you update. And by the way, we're going to learn 3 kinds of updates. But only one of them is called an update. The other 2 are called alters. So we're going to learn how to update rows. We're going to learn how to update column names. And we're also going to learn how to update tables to add or remove columns. But this is our first update. And I think the other 2 happen now, actually. Any questions about the... oh, and by the way, so the condition that I use, right, when I'm using set age is equal to 50, I can use the other comparison operators. I could, for example, use the not operator and set all of the ages to 55 where the ID is not equal to 11, or so on and so forth, right? I didn't plan on going through examples. If you want, I can. But I think it should be pretty straightforward. Oh, actually, let's not run this command, by the way. So what is this going to do? This is actually the first line in our script that we loaded into our database. This is going to drop a table. Drop table student. That will nuke your table. That will blow your table up. We don't want to do that. Also ignore that. We're not going to talk about cascading until we talk about foreign keys. It's actually not really important for our purposes. So for example, I can drop the entire table by doing drop table student. Or let's suppose I want to remove a particular column. I added it by accident. I didn't want to have it. I can go ahead and I can alter my table and drop GPA. That will actually drop the GPA out of my table. I don't recommend that you guys run these queries. I mean, you can if you want to, or you can just take my word for it that they'll work. If you run these, it's going to kill your columns in your table, and you'll have to just recreate them. But it's up to you. Okay. So actually, this sort of closes lecture 2. Oh, and by the way, we're in lecture 3, but this sort of closes lecture 2. You're going to learn how to create what's called a dump. So what is a dump? A dump is a backup of your database. SQL does interesting dumps. It dumps your database into a plain text file that you can actually open up with a text editor. Well, actually, let's do the dump and take a look. So how do you do a MySQL dump? So the name of the function, or the name of the command that you're going to use is actually MySQL dump. So you're going to do a MySQL dump, and as before, you're going to specify the username, the owner of that database, or whoever has permission to dump that database. You're going to do MySQL dump -u, your username, -p, dash databases, and here's where you specify the databases that you want to dump. Oh, and by the way, you could just dump tables too. You would do -- tables, and then specify the name of the table. And let's just go ahead and do the whole database. So it's going to grab everything out of your NetID DB database. And we're going to be using, remember last time we used the indirection operator? That was the arrow pointing that way, pointing into the function. Now we're going to be using the redirection operator, and it's going to take that output and create a file called dump.sql in your home directory. And in fact, actually, if you want to be particularly perverse, you could just dump the output to a terminal. begin by giving the correct password. So now what it's doing is it's taking my entire database, which is actually pretty substantial, and it's just blasting it all into the terminal because my SQL thought that's what I wanted. That's not really useful in any particular sense. So now I've got to actually try to kill this thing. So what I'm going to do is instead of blasting it to the terminal, where it's not really very useful, I'm just going to capture that output using the redirection operator. And you don't have to name your output file dump.sql. In fact, you can name it something more meaningful. You can call it run.sql. You can call it whatever you want. And in fact, actually, you don't even need, you don't even need to name it .sql. Linux and OS 10, they actually don't care what the suffix of your file is. You could call it little green men. Your file, that is, and it would work perfectly fine. But just by convention, it's a good idea to name your files .sql files so that when you're quickly searching through a directory, you know what it is that you're looking at. So, for example, what is today? What's today's date? It's May, right? What's the date? I guess I could look on my computer. So I'm going to call it May24.sql. And I'm going to try to remember my password. Okay, so I have a big database, and it's going to take a little while, so it's just sort of crunching along here. Ignore that, actually. That's you're not going to see that message. You're not going to see a message like that. That's an example that I should have deleted a long time ago. But so what's going to happen then is you're going to have now, if you do ls in your home directory, you're going to have, well, I'm going to do cat. So I've already shown you cat. So I'm going to do cat may24.sql. And now I've captured all of my SQL into a single file. Great. What's the big deal about that? Why do you want to do that? Well, I've backed up, quote unquote, my database now. I have a copy of my database, and what I can do is I can email it to you, or I can email it to you. You're the one making eye contact. I can email it to you, right? So now I can share this database out. I can put my database on another machine, so if my machine gets stolen or blows up, I can go back and I can grab that copy of my database. And again, I have this sort of long, ugly database. I'll just stop dumping it out now. And remember, earlier, we pulled in a really tiny .sql file, example.1.sql, and we created a little tiny table with it. Well, if I use the very same syntax, let's say I create a brand new database, it's completely empty, nothing's in it, and my computer blows up, or gets stolen or whatever, but I have a copy of it backed up. Well, I install a new MySQL database, it's pristine, there's nothing in it. Brand new database. If I run this command, well, I'd have to create this user, I have to create this database out of the empty. But once I do that, if I run this command, it's going to pull in my old database and it'll be a complete restore. Right? I will have then backed up and restored my database. So that's what a MySQL dump does. And I'm not really sure how to squeeze this in here. But oftentimes, during this course, I'll ask the students to create a dump of their database. And and then submit it to me. And I'll upload their database into my own, and I'll poke around, and do creating that way, I would say. But, it's a good idea. Because I'm your benevolent instructor, I'm actually backing up your databases for you. I'm actually archiving your databases.
It's 8 o'clock.
Go, cool. You're not going to lose your data. I do a backup, I think, once a day. I haven't checked it in a while. But in principle, as a data warehouse admin, you are going to want to build regular backups of a data warehouse into the maintenance procedure. MySQL dumps are how those backups are achieved. It's the standard way of doing an SQL backup. So, yeah, that sort of brings to conclusion lecture 2. So, and then, so now I have some more things to start with lecture 3. Do you have a question?
So, we were working on this maybe. I'm going to type in LS or
So, you're working in 2 different environments. You're working on a MySQL server that happens to live on a Linux machine. In fact, actually, without hopefully sounding like I'm proselytizing, production servers the world over all run on Linux. Facebook, Google, it's run on Linux. Your grades here at GW are stored on Linux machines. Payroll, that's also done. In a production environment, you may use Windows or OS 10, for example, to do your endpoint work. But from a systems point of view, the underlying system that's running your SQL server, etc. In a production environment, it's going to be running on Linux. I will bet you, not a lot, but so that's actually what we're using. And so the question that you're asking is the following: those commands, ls, pwd, cp, cd, etc. Those are all Linux commands. And they don't work in MySQL. MySQL has its own set of commands, and the 2 do not mix. So you're actually learning 2 different languages or dialects, so to speak. No, nope. It does not back up automatically. However, it can be configured to. So you actually can configure automatic updates, but that would be done on the host, not the database. And so that's a little bit beyond the scope of our discussion. How different are the commands that are what? If it's hosted on, let's say, it's going to be, they're not terribly different. So on Windows, so some of the commands that are the same are rm to remove something. That's actually the same in Windows as it is on OS 10. cd, cp, these commands are actually all the same. One difference, though, is the following. On Linux, ls looks like the following on Windows. On Windows, you would type dir. So, yeah, there is some overlap, but there's not a lot of overlap. So now, I asked you guys to do something, which I sort of alluded to, well, maybe it's sort of a weak word, but I pointed out last time, and that's creating this table. So I asked you to create a table and populate it, and I give you the parameters of this exercise. I give you the name of the table, the columns to use, first name, last name, etc. Ask a few of your classmates to help you populate this. Now, you kind of get part of this assignment in class anyway. So still, even though it may sound sort of repetitive or redundant, I'd still like you to practice creating your own table. But I have to show you how to do that. So I'm going to take a couple minutes to just walk you through an editor because editing files on an operating system like this presents its own set of challenges. So I'm going to show you, I'm going to give you a quick tutorial through an editor that will allow you to do, to create your own SQL file by hand that you can then upload. But I think if you look at the slide deck, and if you look back at what you've done, oh, and by the way, so when you type exit in MySQL, it's going to save your session. So when you go back into MySQL and start up arrowing, your history is going to be there for you. So given the fact that we've done this in class together, the instructions are also in the slide deck. I think you should be able to create your own tables now unassisted. So let me show you how that's going to work. You should be in your home directory. That's the directory that has the example.sql and your new SQL dump, which hopefully you created a few moments ago. So what we're going to do now is, well, we could start from scratch and create our own brand new SQL file to create a table, but nobody starts from scratch. You always copy somebody else and then make changes, right? That's what I learned in grad school anyway. So what we're going to do is we're going to copy the file, the existing file. The existing file was example01.sql, and we're just going to give it a brand new name. So that new name is, well, I'm going to call it just myfile.sql. So I have to show you an editor. First of all, word of warning to any of you who are using Microsoft Office, it's a great suite of tools, I'm told, but it's not an editor. Microsoft Office is not an editor. When you go and edit documents in Microsoft Office, it's going to embed hidden characters, they're actually called meta characters. Line spaces, tabs, line breaks, etc. And it's entirely inappropriate for doing what we're doing. So never, ever, ever use Microsoft Office when you're doing editing. And when you're doing Word documents, that's fine. But when you're doing this kind of editing, it's not appropriate. It doesn't work. If you do want to use Windows to do this, and you don't want to use My System, then use Notepad. Notepad is actually a real editor that does not sneak meta characters into your files. That's a perfectly acceptable editor. But anyway, you're much better off, I think, for the purposes of this class, using our class server. And the editor that I recommend that you use is called Nano, N-A-N-O. And you open up Nano like this. N-A-N-O, and then the name of the file that you want to edit. So Nano, space, and the name of the file. And Nano is a super friendly editor, comparatively, relatively speaking, because it actually gives you all of the options that you have available right here on the lower bar. So how to get help, how to save, right out means save, how to justify, how to left or right justify, how to remove text, how to undo, etc. So you can navigate with your arrow keys. And let's create a new table. I said create a table called class role. You can call it whatever you want. Well, actually, you can't. You should call it class role because I won't know how to find it. But for this exercise, you can call it whatever you want. I'm going to call my table class role. And I'm basically just going to go down here and make edits. I'm going to edit the table so that it does what I want it to do. Let me change the table name down here also. And for example, some of the things that I might want to do is, well, maybe F name doesn't work. Maybe it's confusing. Maybe I want it to be first name, so I can go ahead and change these things. To be honest with you, I actually forgot what I told you to do in the assignment. Oh yeah, first name, last name, email addresses. Yeah, so I might do something like this. First name, last name. I guess I'll just leave it as it is. I'm going to change age to year. Email. Well, email is not going to be a double, right? I mean, that's going to be a varchar too. Maybe I'll allow up to 50 characters. So it's going to be varchar. Yeah, that's probably good. I mean, you get the idea. So then what you do, it looks the way you want to see, you like it. So here's what you're going to do. We're going to write it out, which means save. I don't know why they press save there. And then we're going to exit. So that caret, but anyway, that the caret, the hat, that means control, the control button, CTRL. So in order to write out or save, hold the control button down and hit X. No, I'm kidding. Hold the control button down and hit O. And that's going to say, okay, file name, write to, and then it's going to say, if you want to edit the file name or change it to something else, you can do that here. You can delete this and you can change it. Or if you're happy with that file name, just go ahead and hit Enter. And I just rewrote that file. So now that file contains this. And if I'm satisfied, then I can exit by doing Control X. And I've exited Nano. So what's in Nano? Or what's in that file? Well, let me open up Nano again. And those changes have persisted. So are there any questions about Nano? We have 7 or 6 minutes left in the class, and I'm actually not going to try to jam the beginning of lecture 3 into the remaining 6 minutes. So I'm going to open it up for questions, but before I do that, there's a final comment. So we're going to meet again on Thursday, of course. For those of you who haven't created this class role table, well, now you can. Now you know how to do that. Once you create that class role table, or at least the file anyway, you can upload it into your database. You can even play around with it now. You can use some queries. You can add data to it. You can do some, actually part of the exercise, but you can add data to it. And once you've added data to it, you can even now dump that database, including your student table and your class role table, and save that. In fact, that's even something you can send to me in an attachment. I'm not asking you to do that, but just for example's sake. So on the beginning of Thursday's lecture, we're going to start on this slide. We're pretty much going to wrap up SQL. There's not a whole lot more that we really need. Like I told you, you're only really going to need to know about 8 or 10 commands in SQL to get by. They're not very many, and they're repetitive. They're usually just sort of variations on a theme. So we're going to close that out, and maybe to help us get through this a little bit quicker, I'm going to ask you to have a look at the slide deck for lecture 3. So you have some sort of idea of what we're going to be doing. And in fact, actually, these commands, you can copy and paste them into your student table. You can copy and paste these into your student table and see what effect they have. Of course, we are going to go over them, but this will be a good way for you to get a head start. So, for example, we're going to look at how to add additional columns. Well, actually, to be frank with you, on slide 3, we actually start with SQL joins, and this is a little bit of a sort of a complicated topic. This actually allows us to make joins in multiple tables. This is where it really gets interesting, and where Mysql, or SQL actually, really gets powerful. Okay. And then, so we are going to close SQL out here. And then what I'm going to do is I'm going to tell you what it means to normalize a database, what it means to put a database in a third normal form. Now, in our data warehouses, we are not going to normalize our databases to third normal form, but we are going to go to first normal form. So yeah, the textbook actually doesn't really, it sort of pays short shrift to database normalization. So I'm going to cover it here. And I'm going to go through an example where I actually normalize a database for you.